Good day students, welcome to math.serve.com. In this clip we're going to be going over how to apply the change of base property of logarithms. To get started, let's take a look at what the change of base formula is, okay? So we're taking a look at what the change of base formula is, assuming you want to go from base A to B, okay? So the change of base formula is as follows: the log base A of, let's say, x. So let's take a look at this expression real quick. This is the base, and I'm going to be calling this term right here the logarithmic argument. So let's assume that we want to convert this logarithmic expression, which is clearly in base A, to a logarithmic expression of base B. Okay, so how do we do that? The formula is as follows. All you do is you first of all write down the log base, your targeted base, which is B in this case, so log base B divided by log base B, and then we'll take the logarithmic argument that will go on top, and then the base of the original expression goes on the bottom. Okay, so let's go ahead and do that. We're going to have log base b of x divided by log base b of a. So this is the formula for changing the base of a logarithmic expression. Alright, let's take a look at some examples. The instructions for the first set of problems is to rewrite as a ratio of first common logs, and then secondly write as a ratio of natural logs. Okay, now let's say we have the logarithmic expression for number 1, log base 3 of x. Let's do the first part as a common log. Now what are common logarithms? Common logarithms are log base 10. Okay, so keep that in mind. One thing about logarithms base 10 is that you do not specify the base. Okay, if you see any logarithmic expression without the base clearly stated, then you can automatically assume that the base is 10 and it is a common log. Alright, so this problem is base 3 and we are to change it to base 10. Alright, remember your formula, the change of base formula. Log base a of x, if you want to change it to base b, is going to be log base b of the logarithmic argument divided by log base b of the base of the original logarithmic expression. So we're going to apply the formula here, and we're going to have the targeted base, which is 10. So have log in the numerator and log in the denominator. Now common log is log base 10, because as indicated earlier, when you're working with log base 10 you need not specify the bases, so I'll take those out of there. Okay, now the argument is x that goes on top, and then the base is 3, and there goes your final answer when log base 3 of x is expressed as a ratio of common logs. Alright, let's box it. Second part, natural log. Now natural log is similar to the common log in the sense that you do not have to specify what the base is. Okay, natural log is log base e, and if you look at this formula right here, it can also be applied to expressing a log of a specified base in a natural log base. So let's rewrite this formula using natural log. Okay, so if you wanted to change log base a of x into natural logarithm, which is log base b, you're simply going to write ln. Ln is a short or condensed way of writing log base 10. So ln of x, ln of the logarithmic argument divided by ln of the base of the logarithmic expression, which is a. So we're going to apply that formula here in converting or expressing this logarithmic expression as a ratio of natural logs. So log base 3 of x can be written as log base e, which is ln of the logarithmic argument x, and that divided by log base e, which is ln, natural logarithm, of the base. Okay, base is 3, so you just insert 3 right there. So that's basically how you change your base. Okay, these examples basically show you how to go from base 3 to base 10 for the first one, and base 3 to base e, and the second example right here. All right, let's take a look at question number 2. What if you were asked to convert the given log expression to base 7? So let's say you have log base 1/3 of 50. So we're going to be applying the change of base formula here again. The base of the given problem is 1/3. The goal is to convert this entire logarithmic expression to log base 7. So to do that, we're going to apply our change of base property of exponents again. Target base is base 7, so we're going to have log base 7 up and down. And then the logarithmic argument 50 goes in the numerator, and then the base of your original logarithmic expression 1/3 goes in the denominator. So that's basically what your converted form will look like. Alright, now let's take a look at another set of examples. Here we are to evaluate each log expression with your calculator. Okay, I'd like you to round to 3 decimal places. 3 decimal places. Now, some might wonder, why are we learning about the change of base property of logarithms? So this example that we're about to do will help you see why you might want to have that change of base property mastered. So let's assume that you were asked to find out what this log expression is equal to. What is log base 5 of 13? Now, since we're rounding and we have like a decimal solution, most of you would think about using your calculators for this problem, which is an accurate approach. But many calculators do not have a logarithmic function where you can specify the base. Some calculators have it, but most do not. Most calculators have just common log and your natural log. So if you have a calculator that you cannot specify the base, and you have common log and natural log, how are you going to be able to find the value of this logarithmic expression here? If you do not know your change of base property, then you cannot solve the problem. Okay, so what we're going to do can be viewed as a translation. The only language that the calculator speaks is log base 10 or log base e, or natural log. So we have to convert this logarithmic expression to a format that most calculators understand, and then you can simply use the calculator to find out what the value of the expression is. Okay, so there are 2 ways we can do this problem. and I'm going to show you both of them. Method 1 will be to use common log. Okay, so method 1, common log. What I'm going to do is I'm going to convert this log to log base 10, or your common log. Let's go ahead and do that. Log base 5 of 13. Using the change of base formula, it can be written as log base 10. You don't write down the number. The logarithmic argument goes upstairs over log base 10. You don't write it down. The base of the logarithm of the original expression becomes the argument in the denominator. Now guess what? Your calculator understands this. It understands common log. Okay, most calculators do. So we're just simply going to enter it into our calculators. Log 13 divided by log 5. Where are you, log 5? And then that's our answer. Okay, now if we want to round it to 3 decimal places, this is an approximation here, so let me indicate that appropriately. We are going to have this is approximately 1.59, and then the 4th decimal place is 5 or greater, so we carry 1 over. 594. That is your final result. Okay, now let's do the same problem using a different method. Method 2 is your natural logarithmic approach. Okay, so using natural log. Now, log base 5, if we want to convert this into natural log or log base e, we'll simply apply the change of base formula again. So we have ln, log base e of the logarithmic argument, which is 13, divided by ln of the base of the original expression, which is 5. As indicated earlier, most calculators have common log and natural log, as you can see here. So we just enter the result into our calculators. Natural logarithm of 13 divided by ln of 5. Now what do you expect to see? Well, let's check it out. Bam, exactly the same thing as you had before. Okay, so whichever method you like. Personally, I like to use natural logarithm because it looks cool. But if you prefer using common log, there's nothing wrong with that. You will end up with the same answer too. Alright, so those are just 2 different ways of finding the value of logarithmic expressions that are not common or that do not have a base of e. Alright, let's take a look at the next example, example 4, which is another example that helps us appreciate the power of the change of base property of logarithms. So in this case, you are to graph the given logarithmic function. Graph the given logarithmic function in your graphing calculator. Okay? Alright, so let's say you're asked to graph y equals log base 2 of x to the third. Okay, so let's say you're asked to graph this. As you can clearly see, the log is base 2. Now, if we pull up our calculators, we can go to our graphing window. Why? Now, how are we going to graph this? If you look at the functions you have, you don't have log base 2 anywhere here. So how are you going to graph something like this? So basically, we have a scenario again where we have a problem in the format that the calculator does not understand. So we basically have to translate this into a logarithmic base that the calculator understands, namely your common log or your natural logarithm. Now, which one do you want? You can pick whichever. I'm going to use natural logarithm. So if I want to change the base of this to natural logarithm, this is going to become the natural logarithm of the logarithmic argument x to the third Alrighty, divided by the natural logarithm of the base of the original function, which is 2. Okay, so what I'm doing here, let me put a side note, is we change to base e. Change to base e, or you can change it to base 10, it doesn't matter. Now we can graph because we have this function in the calculator. Alright, so we have the natural logarithm of x raised to the third power divided by the natural logarithm of 2, enter, and then hit graph, and there you have it. Thank you so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your study of logarithms, do give us a thumbs up. Your positive feedback is very helpful to us. If you have any questions or comments, just place it in the comment section below and we'll be more than glad to support you. Do not forget to subscribe to our channel for updates to other math tutorials such as this. More clips can be found on mathcodeserve.com. Thanks again for watching and have a wonderful day. Goodbye.